Linear equations, part 3. In this lesson, we will be looking at three different things. First, learn to find the equation of a line given a point and another line that is perpendicular to it. Second, learn to use linear models to predict. And third, learn to interpret the slope and y-intercept in context of the problem. So first, we want to learn how to write equations of lines given a point and a perpendicular line. Perpendicular slopes are opposite reciprocal of each other. Opposite meaning the opposite sign. So if it started positive, you have to change it to negative. And if it started negative, you have to change it to positive. And reciprocal means if it's a fraction, or really even if it's not, you need to flip it. So for example, 2/3 is going to become -3/2. Because first of all, you have to flip the fraction from 2/3 to 3/2. And then you also have to change the sign from positive to negative. And then -4, if you have a slope of -4, well, keep in mind that's really -4/1, so its perpendicular slope would be 1/4. We flip the 4/1 to be 1/4, and we change it from a negative to a positive. So let's try an example. Write the equation of a line that passes through -2, -7, and is perpendicular to y equals 3x plus 7. Anytime you're asked to write the equation of a line, you need two things. You need the slope and you need a point. Well, they very clearly have already given us the point. It's -2, -7. But they haven't given us the slope outright. They've given us information to help us find the slope. So we're told that it's perpendicular to the line y equals 3x plus 7. So the slope of this line is 3. So the perpendicular slope to that, remember this is 3/1, so the perpendicular slope would be -1/3. So our point is -2, -7, and our slope is -1/3. So I'm going to use the point slope formula, and we do y minus y1 equals m times x minus x1. So we end up with y plus 7 equals -1/3 times x is -1/3 x. And then this is really a positive 2, so -1/3 times 2 is -2/3. Then we just subtract the 7 from both sides, and we'll get y equals -1/3 x minus 23/3. Similar example, we have to write the equation of the line that passes through 1/4 and is perpendicular to x plus 4y minus 8 equals 0. Okay, so this one, they gave us a perpendicular line, but it's not written in such a way that it's very easy for us to tell what the slope is. So we're going to rewrite the equation of this line to make it easier. So I'm going to try to put it in slope-intercept form. So I'm going to subtract x and add 8 to both sides. And I will get 4y equals -x plus 8. And then divide everything by 4. That gives me y equals -1/4 x plus 2. So the slope of this line is -1/4, which would make the slope of a perpendicular line, our line, positive 4. Because you flip the 1/4 to be 4/1, which is 4, change the negative to a positive. So we have a 0.14 and a slope of 4. So I will again use the point slope formula to do this. Y minus 4 equals 4 times x minus 1. So we do y minus 4 equals 4 times x, 4 times -1, and then add 4 to both sides. So y equals 4x is our final answer. So that gives you an idea how to find the equation of a line given a point and a line that's perpendicular to that line. Okay, next we want to look at linear modeling. Okay, a linear model is a linear equation that's used to model real-world data. So it might happen that you might collect data and put it in your calculator, and you see that the points form what looks like a straight line. You might try to find a line of best fit that would give an approximation of those points. That would be an example of a linear model. So you're using the equation of a line to represent something that's happening in the real world. The two most important parts of the linear equation are the slope, that's the rate of change. It describes how y changes in terms of 1 unit of x, and the y-intercept, which is the initial amount, or another way to put it is the amount of y when x equals 0. Sorry for that stray word there. So I believe this is the same thing. It is. So let's look at an example of how we might go about this. In 1995, 10 million, this should say men, that's where my word's missing, 10 million men in the U.S. lived alone. In 2010, 12 million men lived alone. Write a linear equation to model this data. So whether you realize or not, we've been given 2 points that we can graph. I'm going to make 1995 times 0, just to make things a little simpler, not deal with such large numbers. And if 1995 is 0, then 2010 would be 15. So we really have the ordered pair 0, 10, and 15, 12. So in the year 0, which we're calling 1995, there were 10 million men living alone in the U.S., and 15 years later, there were 12 million men living alone in the U.S. So we can use these 2 points to find the equation of the line. We do that by finding the slope. I get a slope of 2/15, and this happens to be my y-intercept, so if I just use y equals mx plus b in this case, I'll get y equals 2/15x plus 10. So that is a model of this data. We took actual data, the fact of how many men lived alone in the U.S. in 1995 and 2010, and then we used an equation, a linear equation, to model that data. So the next question says, what is the slope? Well, the slope is right here. It's 2/15. What does the slope mean? Okay, here's what I want to make sure you start to get in your memory. Slope is always the change in y per x. So let's look at our equation and think about what the y and the x really are. Y represents the number of men living alone. X is years after 1995. So again, slope, the meaning of slope is the amount of y that changes, or the change in y per x. So in this case, it's the number of men who live alone per year, or the change in the number of men who live alone per year. So keep in mind, we were in millions, so what this tells us, since our slope is 2/15, is that 2/15 million more men live alone each year. Or another way you could say it is, the number of men who live alone increases, because our slope is positive, by 2/15 million men per year. 2/15. So then it asks us, what is the y-intercept? Well, let's look back up here. The y-intercept is always the number that's by itself, the constant, so it's 10. What does it mean? Well, if you look back at the previous slides, the y-intercept is always the amount of y, in this case the number of men living alone, when x equals 0. Well, when x equals 0, we're in the year 1995. So it means that 10 million men, that's our amount of y, lived alone in 1995. So at our original start date of 1995, 10 million men lived alone, which makes sense because we were told that in the problem, that many men lived alone in 1995. So that means our model represents our data pretty well. So again, slope means the change in y per x. The y-intercept is the amount of y in a given year, or excuse me, at when x equals 0 specifically. Okay, so here's some places you can find some examples that'll help you if you need them.